Hi, and welcome to the very new session of again number system. This is session number 9, and in this session what I am going to present in front of you is operation on real numbers. We have this one. After exercise 1.4, we have a new topic which is operations on real numbers. Before starting this topic, let me ask you one thing. What you will do when you just go to a market and purchase some items? There, let's say you purchase two items A and B. You purchase item A, which costs, let's say it costs rupees 75 and 39 paisa. You purchase an item B, which cost rupees 172 rupees and 40 paisa. What will you pay to the shopkeeper? You will pay total as sum of A plus B, which is 9, 7, and it is 7, 4 and 2 rupees 247 rupees and 79 paisa. Here, what this number is? This number is a terminating decimal, and terminating decimal is a rational number. Same is this one, because rational number, and the same is this. This is also rational number. That means what I did, without knowing rational numbers, I am doing an operation on them. What? I am adding them. I am adding these rational numbers. Also, what I did is, if cost of 5 kg rice is rupees 100 and say 40 rupees, what the cost of 1 kg? What you do? You divide 140 by 5, that much rupees per kg, and it comes to be very easy, 2 times and then 8, so rupees 28 per kg. What I am doing? I am dividing them. So in my life, normally daily I am doing these type of things. Not me, even our moms, our dad, they are also doing. We are paying electricity bill, we are paying mobile bills, we are paying other things. Yeah, we are just taking some loans. Whatever we do in banks, each and everything is related with the operation on real numbers, because we are in a real world. We deal with the real. So here, what I am going to take is operations on them. So let me take this operation on real number as I will take first addition. In addition is when two or more real numbers are added, they result in real number. Same is, this same goes with subtraction, this goes with multiplication. These all things goes with them. real number. And real number are rational or they can be irrational. So both of them, whatever I do with them, they result in a real number. It doesn't matter whether two rational numbers are added, they result in a rational number, and if two irrational numbers are added, they result in a irrational number. No. If two rationals are added, Q rational numbers Q1 and Q2, these are two rational numbers, they will certainly result in a rational number. But if two irrational numbers are added or operated, they will result in rational or irrational. I will give you an example. Afterwards, I will give you some examples. This is like that. So, let's go with some examples. What is 5.7? It's a rational number. So, if I will add 3 by 9, what will I get? That is, it's a rational, it's a rational. What I will get? I will get 57 by 10 plus 3 by 9 can be written as 1 by 3. It can be written as 1 by 3. So, I will take the LCM of 10 and 3, it comes to be 30. So, here I have 57 times 3, 1 time of 10, I will have 1, 15, 16, 17 and plus 10 over 30. So, it will result in very much, it will result in 181 over 30. So, again this number is a rational number. What I am getting? The addition of two rational numbers is a rational number. But if I am adding any two irrational numbers, let's say I have a square root of 2 and add a square root of 8, what they will result in? Let's say it becomes root 2 plus 8 can be written as 2 times of 2 times of 2, and it can be taken as like this, plus these two will be taken out and it will result in a 1, 2, it will be like this, and what I will have? 1 time of root 2 plus 2 times of root 2 will be 3 times of root 2, and this is a irrational number. Or I can write it like this, 2 into 3 into 3, and it is 3 times of 9 times of 2 is 18, it will be square root of 18. So, I can write like this, I can write it like this. Okay, this is mixed surds and this is a pure surd. I can write in this. So, in both the ways, these are the irrational numbers. Now, let's come to the another one. Are they always rational? Are they always rational? No. If I will say square root of 2 plus 7, this is an irrational number. And again I will take another, it is 4 minus root 2. It is also an irrational. Just add them. Add them. This will be cancelled out. What I have? I have only 7 plus 4, which is 11, and this is a rational. So, addition of two irrational number can result into a rational or it can result into a irrational. Then same process goes with the subtraction of them. This is again the same thing. Root 2 minus root 2. These are the two irrational numbers. Again it will give you 0. What is this? 0 is a rational. Division also. Square root of 3 is divided by square root of, let's say I will take 12. So it will be square root of 3 over 2 root 3, and 3 will be cancelled, it will be half. So it's irrational. Many number of times we have the division of irrational as a irrational, but many number of times we can have the division of irrational numbers as a rational also. So it is not a very hard and fast rule. We always get only the same type of result. Clear? So this is one thing which I would like to put in front of you. Okay. Then after this, let's move to some more thing, and let's check whether the operation which I am just going to do will result into a rational or a irrational number, in which it will result of. So this is one thing. So let me have, say if I will do pi minus 3.14. Now what is this? Will it a rational or irrational? An example this is. By default, what normally a student will do, once we are doing the problems of areas and and the circumference of a circle, we have been given pi as 3.14. But you know, the pi is an irrational number. We have discussed this in previous sessions. This is an irrational number, as well as this is a rational number, because it is terminating number. Now, how a irrational number can be equals to a rational number? But we have been given like this. Why we have been given? Because we had to solve a question. We had to solve a question, and just to make our question easier, we give pi as 3.14, or normally we take it 22 by 7. The two decimal places of 22 by 7 results in this one. So this is how we have the value of pi. But this is an irrational and this is a rational, and the subtraction of irrational and rational will result into a irrational number. Don't think it as 3.14 minus 3.14 and it will result 0, which is a rational number. This will be a wrong answer. Perfectly wrong answer. 100% wrong. You had to think with your logic what this is given, irrational number and a rational number. How oranges and apples will be compared? No. Let's say this is orange, this is apple. They can't be compared. They can't be compared. We had to make separate. They are separate from each other. So this is one example, and I think if this example is very much clear to you, so and let's move to the another one. We have another one for this, and I will give you an example. Let's say add the difference of root 3 and root 48 and root 8, and let's say we have 96. We have to add them. So first of all, let's say there's the difference of them. So the difference of them, what is the difference of them? What is the difference of them? Take the difference of both of these, then we will have to add. So difference of root 3 and root 48. So the difference of them is root 48 minus root 3. So 48 can be written as 16 into 3. This can be taken as, now 4 times of root 3, when we subtract from it 1 time of root 3, we will have, so this is the first. Now the difference of root 8 and root 96, what we will have? We will have root 8 can be written as, this is 96 minus root 8, and it will give you 96 can be written as 32 into 3, okay, 32 into 3, or it can be written as 16 into 6, minus 8 can be written as 4 into 2. So it will be 4 root of 6 minus 2 root of 2. This is equation number 2. Now just add them. Now how will we add? Now this is the operation we are doing. The add we are doing is, we are adding them. It is 3 root 3 will be added to 4 root 6 minus 2 root 2. So this is the final answer. There is nothing which can be taken common from both of them. So we put it as it is, or there is only the thing which we can do. Clear? Let's see some question on the multiplication. Multiplication. Let's say I'm taking first of all rationals, irrationals I'm taking, because irrational are quite important for us to solve and make trouble also. So first of all, let's say I have a as, I have taken a as, it is root 3 minus root 5, and b I have as root 10 plus root, okay, let's say I have only root 10, or let's say I take it as root 15. So what is a times of b? A into b, it will be root 3 minus, now the same thing we will do, a minus b into c is nothing, it is a times of c minus b times of c. See, okay, we will apply the properties of exponents. A times of square root of b is equal to square root of ab. So this will be root 3, it will be into 15 minus root 5 times of 15. So it will be, what it will make it, 3 minus, I can write like this, I will take 3 root 5 minus, so this is the perfect answer. This is how I can multiply them. Let's take another operation. Let us do the same question. I will do another operation. I will do let's say find value of a square plus b. We have to find the value of this. So what is the value? The value is or 2 times of b. I will take 2 times of b. So the value is whole square minus this. What it comes? We know a minus b whole square is equal to a square minus 2ab. So it will be this minus 2 times of this it is like this. Okay, 2 times of this. So we take 2 times of this. So it is root 3 square is 3 minus, why root 3? The square root of a is a raised to the power half raised to the power 2 is equal to a raised to the power 1. This will be cancelled. It is equal to a. So it is 3 minus 2 times of 3 into 5 plus 5 minus 2 root 15. Now what this becomes? 3 plus 5 I will take together minus 2 root 15. Okay, this is, and I have to add them. This is addition. I have to add 2 root 15. So this will be added. Just written is by default. I written it. So it is 3 plus 5, which is 8. Okay. So the operation on two irrational numbers. This is irrational. This is irrational. This is irrational. This is irrational, and they result into rational. So this is how the operation into two irrational numbers can also result into a rational number. Clear? So I'm pretty sure you have been through all these things, and I will continue this session with another one. So before in the second part also I will continue this. So before concluding this session, let us recollect the main points once again, and just take another session of this. So this is this operation of real numbers we have, and we have done the operations on rational and irrationals, because all the real numbers are consisting of rational and irrationals. So what we have, the sum or difference of a rational number or an irrational number is a rational number. This is false statement is this one. We have sum of rationals, sum multiplication and division or and subtraction of rational numbers is a rational. Moreover, for irrational, the operation can result into rational or irrational, both. Now, for division of a rational number, the division of rationals, these are the P and Q, they are two rationals. It is a rational, and Q not equals to 0 also result in a rational. But the division of any two irrational numbers can result into rational as well as a irrational. So this is all we have for this in this session, and we are going to meet in the another session, part 2 of this one, in which we will deal with the representation of a number on the any number, any type of rational or irrational number on the number line. Okay, so we will deal with that, and we will know how the formula will be. Okay, so have a nice time. Thank you.